In this lesson, we will determine the ratio of elements in a compound from its chemical formula. When we look at chemical formulas, we notice several things. One, chemical formulas contain symbols for elements. So here we have C for carbon, O for oxygen. We have Mg, notice the capitalization on this symbol, for magnesium. We also have subscripts. And in many places we don't see subscripts, but anywhere there's no subscript, it is an implied 1. So you can pretend that there's a 1 after every element that doesn't have a number, although we never show those in the actual chemical formula. The last thing we see are the parentheses in some substances. And so when we look at this compound, this happens to be magnesium nitrate here at the bottom, what we see is that we have this group, NO3, which is called nitrate. The important part of this is that we have these parentheses, and what they tell us is that this NO3 group is acting as a group, and there happen to be two of those groups. So when we look at the number of atoms, we have to remember that and pay attention to that with that 2 that's outside the parentheses. So let's look at a couple of examples on how we can determine the number of each type of atom in a particular molecule. So what I'm going to do first is actually write down the elements in the molecule. So here we have hydrogen and oxygen. I look at the formula and I notice that by hydrogen it has a subscript of 2. So there are 2 atoms per molecule of water. For oxygen, there's no subscript, which is an implied 1, so there's 1 atom of oxygen per molecule of water. Now, when I look at the magnesium compound, magnesium nitrate, I'm going to start the same way. I've got magnesium, I've got nitrogen, and I have oxygen. We'll start with the magnesium because we notice that there's no subscript, which is an implied 1, so there's 1 atom per molecule. Next, we look at the nitrogen. The nitrogen inside the parentheses doesn't have a subscript, so we have our implied 1, but it is inside the parentheses, which means that the number outside the parentheses goes with everything inside the parentheses. So while NO3 has 1 nitrogen, the entire molecule, when we look at the whole thing, actually has 2 nitrogens per molecule. Now when we go to the oxygen, we see the NO3 group has 3 oxygens, but there are 2 NO3 groups for a total of 6 atoms per molecule. And what we will see is that eventually we will start to use these as a relationship to start to do some quantitative calculations.